Taking up where we left off last week, we've introduced three primary equations that we're using to describe our data. The mean is the equation we're using to determine the central tendency, and then we have variance and standard deviation to help us understand the spread and the shape of our data. So hopefully you've had a chance to practice calculating each of these metrics and have a pretty good feel for it. So what are we going to do with this information, right? We have histograms, we have metrics of variance and central tendency. How does all this help us understand our data? So today we are going to dive in and start on our journey to try to become intelligent consumers of data. Let's take a look at some recent COVID-19 testing information. You may have seen the headlines that said that there are a lot of states, particularly in the Southwest and the West, that are showing an increase in cases. In fact, that the drop in cases throughout the United States as a whole is mostly due to New Jersey and New York. New Mexico is often cited as one of the states that has seen an increase in the number of COVID-19 cases, and our neighbors, Arizona and Texas, are often cited as some of the largest increases. So I want us to go ahead and dive into some of this data and see if we can analyze it and think a little more intelligently about it and see what the results actually might be. So what I've done is I have collected all of the data of the number of new cases reported through testing for New Mexico and Texas. So we can take a look at both of these states, and I've collated that on a Google Sheet. So we are going to hop on over to Google Sheets and take a look at that now. We're looking at the data that I talked about right now, where I have the number of new cases per day reported in New Mexico and Texas. So this is our raw data. We have learned a couple ways of trying to get a better understanding of our data and what it's telling us. So let's go through and do that real quick. So we'll start by constructing our histogram for each state. So we will come over here to New Mexico. We will insert a chart. We will select the histogram, and looks pretty solid. We can check the probably use about a 25 for the binning. Okay, so this is what the data looks like. So how would we describe this curve? Take a minute, think about it, and then come back. All right, so hopefully you come up with some descriptions for this curve. I would say that it is unimodal, right? That there's a single peak, and generally it's fairly symmetrical around the mean, except that we have this tail out here, this skew, right? So it is right skewed. And it's this data out here, which is some of the more recent data, that has led people to say that the number of cases in New Mexico is rising. So certainly at first pass, that is suggestive that we're seeing an increase in cases. Okay, let's take a look at Texas. So we'll select our data. We will insert the chart. Right. It is a histogram. We will customize it. Probably need to use a bigger binning for Texas. The data is a little, so we'll just go to a slightly bigger binning. So you can see the histogram looks quite a bit different. I would use pretty much the same description, that it's probably unimodal. It has one peak, but it has a much longer tail, right? This right skew is much heavier. And sure enough, if you look at the data out here is the more recent data. Again, suggestive that there very well might be an increase in cases. All right, well, that's not the only way we can describe our data. I mean, just looking at these two histograms, we can see that there's some pretty big differences between them. So let's get our central tendency, let's get our variance and standard deviation scores, and take a closer look. So I'll go ahead and start calculating those right now. I've gone ahead and calculated these values. So the mean number of cases per day for New Mexico has been 116, whereas the mean for Texas has been 414. The variance for New Mexico has been 3,202, whereas Texas, it's a much larger, almost 150,000. Sure enough, the standard deviation shows a similar difference, with 57 being New Mexico and 387 being the standard deviation for Texas. So this helps us sort of understand that, in numbers what we can see visually. Right? We expect the mean for Texas to be a lot larger than New Mexico. You see, New Mexico goes from 0 up to about 325, whereas Texas goes all the way up to 1,700. Right? Whereas there's a lot more variance, there's a lot more spread of the data around Texas than there is New Mexico, which is a lot more clustered around that mean of 116. So we can see both graphically and also in the numbers the differences between the two states. So we're still left with the question about whether or not there has been an uptick in the number of cases recently. Before we begin this, though, we have a little bit of a problem. How do we even compare Texas and New Mexico? It doesn't even make a whole lot of sense because there's a lot of differences between the two states. Right? It doesn't make much sense to compare them. Is the fact that Texas has had a lot more cases of COVID-19 mean that they have a higher infection rate? No, not at all. I mean, first of all, we have to deal with the fact that there's a much, much larger population in Texas. They've done more testing. There's all kinds of factors that are going to differentiate between New Mexico and Texas. And doing a direct comparison between them doesn't make a lot of sense. We need to find some way of presenting our data or transforming our data such that we can do direct comparisons, so that a comparison in New Mexico can be done the same in Texas, that we can do direct comparisons even though the data is very different. How do we do that, right? How can we compare two very different data sets? And that comes into transforms, and we're going to introduce the Z-transform, one of the more powerful transforms in the arsenal of statisticians, in the next video.